Hello everyone, welcome to the last lesson of this chapter, Chapter 6, Lesson 6, Systems of Linear Inequalities. We're going to put it all together today. By the end of the day, you will be able to solve systems of linear inequalities by graphing. We're just going to do some graphing. You'll also be able to model real-world situations with systems of inequalities. So we'll do some graphing, we'll do some modeling, because you guys are model students. Aww. Just a quick reminder, just like a system of equations was two or more equations together, a system of linear inequalities is made up of two or more inequalities. And just like the solution of a system of linear equations is any point that makes all of the equations true, whether that was their intersection or them being on the same line or whatever, the solution of a system of inequalities is any ordered pair. It's going to be a point on the graph represented by an xy coordinate that makes all the inequalities in the system true. So just like you found the intersection of two lines, here, since they're inequalities with shady sides, the solutions lie where the graphs overlap. Okay, I'll show you what this means. So first, what we want to do is we want to graph both inequalities and find where they overlap. So if you've got your beautiful graph, what we're going to be doing today is you'll graph one equation if it's like, one inequality if it's like that kind of deal. Cool. All right, let's say this guy goes like here, whatever, and then you graph another inequality. Let's say he looks like that or something. And he's got like this area right here, then the solution is going to be this area right here where they overlap, not the axis itself. I mean, there, this triangle guy, that area. There are two ways to show this. Some people will go all out with the 3 different kinds of shading, and that's fine. Other people will say, hey, you know what? I'm just going to write a cute little reminder to myself to shade, this part on this line, and then this part on that line, and then where they overlap is in fact the solution, and they only shade this part. That's also valid. I'll show you both ways. So here, let's graph this equation. Let's graph the system of equations. First, we're going to graph y is less than 2x minus 3. So first we'll start out by graphing the line. It's got a y-intercept at -3. A slope is up 2 over 1, up 2 over 1. Like that. I'll draw my line. But, oh, you know what, guys? It's not an equal to, so we need to change this. Oh, I can't. Oh, I can make it dotted. Ha-ha. I like the dashed one anyway. Check that out. That's so cool. We will do this all at school. Okay, so we drew that, and now we need to find a test point. Let's use 0, 0, because it's our best friend. Is 0 less than or equal to 2 times 0 minus 3? Well, is 0 less than -3? Oh, rip. It is not. So we're going to graph that side of the equation. We're going to shade that side of the inequality, which is that a guy right there. Let's graph our second line. 2x plus y is greater than or equal to 2. I'm going to graph the line 2x plus y equals 2. So that tells me that if I get rid of this guy for a hot second, 2x equals 2 means x equals 1. So that's my y-intercept right there. And if I get rid of my x guy, where'd my y guy go? Oh well, I'll just have to rewrite him or something. Oh, there he is. Okay, y equals 2. Yay. So graph that line. Is it supposed to be solid though? It is. Oh, it's a little off. Haha. Take that line. So cool. Well, that's close enough. Remember graphing, we're looking for close enough counts anyways. And now we need to figure out, does 0, 0 make this true? Is it true? Or we don't need 0, 0. But it's easy. Is it true that is 2 plus 0 plus 0? No, that's still not true. Aw, man. So we need to shade in the opposite side. That's the sound that shading makes, by the way. Okay. If you want to leave it like this, I'm okay with that. That's fine. If you would rather note, oh, hey, I need to shade the solution area, which is this area right there, that's fine. You can do that, especially if you don't like the use of color and you just want to go here. You can get rid of the shady part and then you only have that. That's totally fine. Go for it. So you don't need multiple colors. I like to use multiple colors because it helps. Now we need to find a checkpoint. Let's use 4, 0. Is it true, if we use our checkpoint 4, 0, is it true that 0 is less than 2 times 4 minus 3? Yes. Is it true that 2 times 4 plus 0 is greater than or equal to 2? Yes. So we did something right. Yay, checkpoint. Okay, now can you write a system of inequalities from a graph? Well, let's break it up. Let's write the orange one first. Ta-da. And then the blue one. When I look at this orange line, I notice that it has a slope of 1. So I'm gonna look at it like y equals mx plus b. It's got a slope of 1, so they give us y equals x, and its y-intercept down here is negative 1. Y equals negative x minus 1. Now that I've got that equation, I also see that it's a solid line. So it's either going to be greater than or equal to or less than or equal to because it's solid. So let's use a test point. Let's use 0, 0 as our check. We're going to say, okay, is 0 greater than 0 minus 1 or is 0... Sorry, that's less than. Or is 0 greater than 0 minus 1? Well, 0 is not less than negative 1. 0 is greater than negative 1. So we don't want a less than. This needs to be a greater than or equal to. So the inequality that we need, full orange, 0 is greater than or equal to x minus 1. That was our orange guy. Now let's look at our blue guy. In our blue equation, we'll still do y equals mx plus b. You don't have to, but I prefer it. Now when I look at my slope, I see it starts at 5. Oh, hey, it starts at 5. Y-intercept. Then to get to this next point, we go down 1 over 2. So that's a negative 1 over 2. Awesome. It's not going to be equals, though. It's going to be either strict greater than or less than. So let's use a nice little checkpoint here. How about, I don't know, 0, 0. Is it true that 0 is less than negative 1/2 of 0 plus 5? Or is 0 greater than negative 1/2 of 0 plus 5? Well, 1/2 is 0. 0 plus 5 is 5. 0 is less than 5. 0 is 0 plus 5. 0 is not greater than 5. So we want to go with a strict less than here. I'll make it dark blue so it like super matches the graph. And there you go. That's our system of equations. Inequalities. System of inequalities. Bye-bye. Awesome. When are we going to use this in real life? Well, let's say you need to plan your life after school today. And here's what you know. You know that you can spend at most 6 hours playing basketball and doing homework. So you've got 6 hours of free time when you get home to do stuff. So maybe you get home at 4, go to bed at 10. Great. Of course, setting aside an hour to eat dinner and watch Jeopardy. Of course. You want to spend less than 2 hours. Let's go back. Let's go back to our yellow. It's because this is going to be pretty. You want to spend less than 2 hours playing basketball. You need to spend at least 1.5 hours on homework. What is a graph showing how you can spend your time? Okay, well, first let's figure out how are we going to spend our time. We're either going to be playing basketball. How about hours playing basketball? Or we'll be doing homework. So hours doing homework. Okay. Let's let X be the number of hours playing basketball, and let's let Y being let's let Y equal the number of hours spent doing homework. Well, what do we know? Let's look at all of our information. First, we know that we can spend at most 6. So we spend less than or equal to 6 hours playing basketball and doing homework. We found that out from our pink statement. We also want to spend less than 2 hours playing basketball. So that means basketball needs to be less than 2 hours. Oh, by the way, this is total time. This is basketball practice, I guess. And then finally, we know that we need to spend at least 1.5 hours on homework. So our homework hours needs to be greater than or equal to 1.5. This is our homework time. Okay. Now let's graph them all, starting with our total time. I look at this guy and I see, okay, that's or equal to, that's going to be a solid line. And that's in standard form with our intercepts at 6 and 6. So here we go. Boom. This is not perfect. Come on, you're supposed to be perfect. Come on, technology. That's okay. Nobody's perfect. I gotta work it. It did exactly the same thing, didn't it, guys? Close enough counts. It's a graph. Okay, cool. Now, less than. We're going to plug in a test point. 0, 0. Is 0 plus 0 less than or equal to 6? Yes. So we're going to shade, but I'm not going to shade yet, and here's why. We're going to shade that side. We're going to shade towards 0, 0. Now, guys, we do have some constraints that we need to consider. We do need to have positive time, so we can't go past our X and Y axes. So I didn't need to shade like this part right here, for sure. Right? Now we need to graph our basketball. So our basketball is X is greater than 2. Just going to give us a vertical line, but it needs to be dotted, and it needs to be right on 2. Come on. Ha. Ha. Okay. This needs to be dotted or dashed because it's less than 2, but not exactly 2. We can spend up to 2 hours working on basketball. So less than 2 hours is going to be shaded this way. Again, time needs to be positive, so we're not even going to go into the negative realm. Ooh, the magical negative realm. Haha, yay! Finally, we've got our homework time. Our homework time needs to be Y is greater than 1.5, which is going to go here. Sorry, greater than or equal to 1.5, which is going to go this way. Now, greater than means it's going to be above that. So we would theoretically shade all of this time. But guys, we're starting to lose track of where our shading, where our solution is really going to be. Because remember that our solution was where all of the inequalities are true. And, okay, well, you get the idea. And way out here, this is only making our homework true. But we don't get to we can't spend this much time on basketball, so that doesn't work. Okay, it's only going to be this side and here, but with all these colors going on, it's hard to figure out what's going on. So instead, I'm just going to look at the overlap. The overlap is anywhere above the blue line, kind of underneath this pink line, I guess, and to the left of this yellow line. So the area where they all intersect is this area and this kind of trapezoidy guy right here. Oh, that almost worked. Anyway. This area right in here. This is our solution. This is how much time we can spend on homework and on basketball. So remember that X is hours playing basketball. So we could spend, 1 hour on basketball and 2 hours on homework, and that's fine. Or we can spend half an hour on basketball and 5 hours on homework, and that's great too. We cannot spend more than 6 hours on anything, obviously. So here's our graph of our solutions. Ta-da! Oh, and then graph the system. That's the last step. We did that. Cool, huh? Hey, there's system of inequalities. If you want, you could have shaded the whole graph. I just like to show where the solution is using my fancy arrow trick. You do not need the fancy arrow trick like this guy right here. That's totally okay. Yeah, just graph them both. Solution is where they overlap. Have a great time in your homework.